Good morning again, everybody. And we will start with our lecture today. But before that, I would again like to remind you, somebody had asked me questions regarding two things. One was about the hostel admission. Okay, there is still no clear directives from the university, and we go only by the university directives. Okay, so since there is no information from the university, right now we are not in the process of giving the hostel admission. Okay, we'll welcome Inamul. Right. So until the hostel admission start, okay, and you get the hostel facility, we are going to continue with the online mode. Okay. If there is anything important, then we will let you know by either on this WhatsApp group, or maybe we will call you, or we can send you emails also. Okay, there was another question asked by somebody about the fees. Okay, so the deadline for the fees, I think, is extended by 10 days. So you need not worry immediately, right? And if there is anything important about the fees also, that also we would let you know on this WhatsApp group. Okay, I'll try to share my screen first. Can you see my screen?
Yes, sir.
Yes, sir.
ओके.
Yes.
मी थोडा स्पीकरचा व्हॉल्यूम वाढवते, मला तुमचा आवाज नीट येत नाही. ओके. So the topic which I'm going to start today is a very general topic about bioseparations. Bioseparations actually mean that it talks about the biomolecules, different types of molecules in biological systems, such as proteins, or it could be lipids or carbohydrates or anything like that, even the nucleic acids, and how we separate them. Okay, so this is just an introductory topic, I would say, and we have already done one aspect of this, one part of this, and that is electrophoresis, isn't it? So electrophoresis was actually, or rather it is a technique for separating biomolecules. I have already covered that first. Okay, and then I'm coming back to this introductory topic. The reason for this kind of a U-turn, I would say, is just to make you understand the important concepts more properly. Okay, since you know about electrophoresis, I think whatever I'm going to discuss with you today, that will be more clear to you. Okay, so basically the question is, why do we want to separate biomolecules? Okay, again, take for example proteins or nucleic acids, because these are more commonly common molecules which are separated for some reason or the other. Okay, they are studied in detail, they are characterized, isn't it? So the question is, why we want to separate these proteins, or why we want to separate nucleic acids? And the reason that there are two important reasons, although on the slide I have written something, okay, but then we can always make corrections in the slide. Okay, so there are two reasons why we want to separate the biomolecules. One reason is that we want to, obtain purified preparations, okay, pure preparations of the biomolecules, and these pure preparations are then subsequently used for some kind of application. Okay, for example, if it is an enzyme, then we would separate an enzyme for certain industrial purposes, isn't it? As a catalyst, as a biocatalyst. And we also want to separate the biomolecules for one important reason, and that is to characterize a particular molecule. So sometimes we do not know much about a particular molecule. Okay, we need to know more information about that molecule. So what we do is before we start any kind of studies on the biomolecule, we must obtain it in a very pure form. Why we should have a pure form? Because if the protein is impure, or if the DNA preparation is impure, then whatever studies we do and whatever results we get out of it, these results are not correct, we will say. Okay, because there were some impurities in the sample. Okay, So sample impurities would be taken as a characteristic feature of the biomolecule when it is not actually so, isn't it? So we have to purify the biological molecules, right? The interfering substances, whatever are there, or the contaminants as we call them, these contaminants should be removed so that the preparation is very pure, and the pure preparation can be further studied or it could be used for certain applications. So these are the two basic reasons why we separate a biomolecule. Okay. The next question is, how do we separate the biomolecules? On what basis do we separate them? And the answer to this question is not very difficult. Okay. If we know the properties of that molecule, then based upon the differences in the physical or chemical properties or biological properties of the molecule, we can separate the different molecules. Do you understand what I'm saying? मी
Yes, sir.
आता जे काही बोललो ते कळलं का तुम्हाला?
Yes, sir.
काही जर तुम्हाला शंका असेल तर तुम्ही मध्ये मला इंटरप्ट करून विचारू शकता. ओके. आणि ती हॅबिट असायला काही हरकत नाही, ती हॅबिट तुम्ही लावून ठेवा. इफ यू हॅव एनी क्वेश्चन यू कॅन इंटरप्ट अँड आस्क मी, बिकॉज देर आर चान्सेस यू विल फॉरगेट अबाउट इट लेटर, आणि मग ते नेमकं एक्झाम मध्ये तुम्हाला त्याची अडचण होईल. कळलेली नसेल गोष्ट आणि ती नेमकी एक्झाम मध्ये येते. ओके. And the next slide here shows what are the different strategies we can use to purify biomolecules. Okay. Now on this slide I have shown you three different, there's a table here, and in the table I have three different columns. One column tells you about the molecular peculiarities or the molecular characteristics of a particular biomolecule. Then based upon the molecular characteristic, there are certain physical properties which are associated with the molecule, and based on these physical properties we would separate the molecules using different techniques. So I have given you different techniques in the third column. Okay. So we go to number one characteristic, that is the polarity of a molecule. What is the meaning of polarity? Chemical polarity we would call it. Do you know what does the word polar mean? Polar or polarity?
So in the two ends,
Yes.
charge, etc.
Yes. Polarity means there are two poles, isn't it? Just like the Earth has two poles. One is the North Pole and the other is the South Pole, isn't it? So on any molecule, because of the charge distribution, we can say, okay, one of the pole or one end of the molecule would have a positive charge and the other would have a negative charge, and therefore there is a polarity in the molecule. Now because of the polarity, the molecule has different properties. For example, volatility. Volatility is because of polarity, isn't it? Solubility of a molecule. For example, did you know that polar molecules will always dissolve polar solutes? Okay, polar solvents will dissolve polar solutes. Do you know this?
Yes, sir.
We have two things, like say water soluble material and water insoluble or fat soluble, isn't it? So molecules which are soluble in water are not necessarily soluble in oils. For example, oil is not soluble in water. Why oil is not soluble in water? Because oil is a non-polar molecule and water is a polar molecule, isn't it? So there is a rule that we have studied earlier: like dissolves like. Do you remember that? Like dissolves like. Okay. So polar solvent and polar solute, they are miscible, right? So and the third important property of a biomolecule is adsorptivity. Okay, adsorption, that is attachment of a particular material, okay, a molecule on a surface, and that is because of some weak interactions, weak forces, you can say, and that also is because of polarity. Okay. Now if you know that volatile compounds okay, volatile compounds can be separated using a technique which is called gas liquid chromatography. Have you heard about this word, gas liquid chromatography? Okay. In this particular session, we are going to study about chromatographic techniques. Okay. And before going to the chromatographic techniques, I am trying to make certain concepts clear to you. Okay, so therefore this is an introductory talk about the bioseparations. Okay, how many of you have heard about gas liquid chromatography? Nobody? Amol, want to say something? Yes, Amol.
हा सर.
काही बोलायचं आहे का तुला?
सर गॅस लिक्विड क्रोमॅटोग्राफी ऐकलेली सर.
ऐकलेलं आहे. ओके.
होते आम्हाला इंट्रोडक्शन, थोडं इंट्रोडक्शन हे पार्ट होतं.
Okay, very good. Okay, so at least introductory, probably you know that any chromatographic technique involves two important things. One is the mobile phase and the other is the stationary phase.
Stationary.
Correct? Gas liquid chromatography मध्ये stationary phase हे liquid आहे, for example. पण mobile phase जो आहे तो काय आहे? Gas आहे. Gas is the mobile phase. Okay, and your sample molecules therefore should undergo conversion to the gaseous phase, or your sample molecule should be gaseous. Okay, so if they are gases, then the gases will be carried through the mobile phase and they will be separated in this particular combination of the stationary phase and the mobile phase. That is, they will get partition between the two phases. तुम्हाला माझा आवाज येतोय का क्लिअर?
हो सर.
विचारतो याचं कारण काय
Yes, sir.
बिल्डिंग मध्ये काही काम चालू आहे सध्या, ड्रिलिंग वगैरे असं काम चालू आहे. आनंदाची गोष्ट अशी की तुमचे पायगुण चांगले आहेत आमच्या डिपार्टमेंटला, कारण आपल्याकडे आता व्हर्च्युअल क्लासरूम तयार होती आहे. ओके, आर डिपार्टमेंट ऍक्च्युअली, राईट? एव्हरी डिपार्टमेंट विल हॅव वन व्हर्च्युअल क्लासरूम. ओके, तर हे तुमच्यासाठी चांगली गोष्ट आहे. तुम्हाला अजून चांगल्या टीचिंग लर्निंग टेक्निक्स तुम्हाला बघायला मिळतील आणि चांगल्या पद्धतीने तुम्हाला इथे एज्युकेशन मिळू शकतं अजून. आणि तो त्रास मात्र आपल्याला 1-2 दिवस करावा लागेल. इन्स्टॉलेशन चालू आहे. Okay, then another thing is solubility. Okay, solubility differences are there. Okay, and based upon these differences in the solubility of different molecules, they can be separated by another technique which is called as liquid chromatography. Okay, ह्याच्यामध्ये काय, stationary phase is the liquid and mobile phase also is a liquid. माझं इंटरनेट कनेक्शन थोडंसं अनस्टेबल आहे. आय एम गेटिंग दिस मेसेज ऑन माय स्क्रीन. तुम्हाला पण दिसतोय का तो मेसेज माझ्या स्क्रीनवरचा?
नाही सर.
ओके, तुम्हाला दिसत नसेल कदाचित. ओके, एनिवे, बट at least if there is any problem you cannot hear me, then you tell me, because in the online mode has this problem that I will go on talking without knowing that the connection is cut off and you are not able to hear me. Okay, so in such a case you can even call me up, there is no problem. You can call me and tell me that you are not able to listen to me. Okay, then the third important property is the adsorptivity. That is the ability of a particular molecule to adsorb on a surface. And because of this adsorption phenomenon, it is possible to separate different molecules which have different adsorption capacity or different ability to get adsorbed on a particular surface. And on this particular, on the basis of this property, we have another technique of chromatography, which is called liquid solid chromatography. Right now, you don't have to bother much about the different technical terms I'm using, the different techniques I'm telling you about, because you are going to study each and every technique in detail in this particular unit. Okay, this unit is called chromatographic techniques. Okay. What we are trying to understand in this particular discussion is just that different molecules have different characteristics. Based upon the different characteristics, they have different properties. Okay, and based on these different properties of the biomolecules, we have different techniques which are used to separate them. Okay, so for example, some molecules are ionic in nature. They undergo dissociation. Okay, and they are prone to get converted into ionic form. So when they have ionic property or ionic characteristic, then they have the property of carrying certain charge. Okay, or rather I would say charge distribution. Just rather than saying just charges, I would say they have a certain charge distribution on the surface. Okay, so they are either positively charged, net positively charged, or net negatively charged, or they could be neutral molecules. Okay, so based upon the charges we have two different techniques. Out of the two techniques we have already studied one technique, and that is electrophoresis. बरोबर है कि नहीं?
Yes, sir.
So now the other technique which we are going to study here is ion exchange chromatography, which is based upon the ionic interactions. Okay. Then another useful characteristic of the molecules is the molecular mass or the size of the molecules. And based upon this peculiarity of the molecule or feature of the molecule, there are three different important properties of the molecule. One is diffusion. Okay, the capability or the ability of the molecule to diffuse in the space. Okay, the space could be a space or medium. The medium could be a liquid medium, it could be a solid medium, or it could be a gaseous medium, whatever it is. Okay, so based on diffusion, we have these important techniques. One is called gel permeation chromatography. Have you heard about this technique anytime? Gel permeation chromatography.
Yes, sir.
Have you?
It's also called. Yes, sir. I studied it.
Okay, very good. And how many of you have read about or studied about gel filtration chromatography? Gel filtration. Gel filtration and
Sir,
gel. Yes.
Sir, I think gel permeation chromatography.
Okay,
Yes,
see,
sir.
gel permeation and gel filtration are exactly one and the same. Okay, I have just used another term for the same concept. Okay, both mean one and the same.
And sir, chromatography is the another term.
काय काय ऐकायला नाही येते. नाही आवाज कट होतो.
Molecular sieve chromatography is the another.
Yes, wonderful. Okay, molecular sieve chromatography is another name for the same technique. Okay, it is the same technique. Right? Okay, Pragati, could you hear?
Yes, sir.
Okay. हा त्याच्यानंतर अजून कोणते टेक्निक्स आहेत? We have dialysis. Okay, dialysis again is based upon the phenomenon of diffusion, or you can say the sieving effect. Okay, and then the third technique is ultrafiltration. Okay, these are all size-based separation methods. The other important property of molecules is the sedimentation behavior. Okay, you know that if you put mud in water, then after some time, if you allow that water to stand still, then the mud particles will all settle down. That is called as sedimentation. Okay, yes. That is because of the molecular size or molecular mass. The molecules which have a higher mass will settle down more easily, and the molecules which are not very heavy or they are light particles, these particles will actually remain for a longer time in suspension, isn't it? Bacteria तुम्हाला माहिती आहे, bacteria पटकन खाली बसतील का? Do bacteria sediment down? Okay, if I give you a suspension of bacteria, will the bacteria sediment down easily?
Not easily, sir.
Not easily. Then what do you have to do?
Centrifugation.
Kai?
Centrifugation.
We can.
Yes. Very good. So you carry out centrifugation for it. Okay. Centrifugation केलं म्हणजे तुम्ही काय करता? त्याच्यावरचा gravitational force वाढवतात त्या particle force. And because of that gravitational force or applied gravitational force, the bacteria would sediment down or they will settle down. Okay. This is also size based. आणि मग तिसरी property आहे, that is called mobility. Okay, हे आपण already शिकलेलो आहे. Mobility by virtue of the size. In electrophoresis, for example, we have seen that smaller molecules or smaller mass molecules will be more mobile. Okay, they travel very fast in the electrophoretic gel, whereas the heavier particles or heavier molecules will take more time to migrate from one end of the gel to the other end.
Sieving effect.
Yeah.
त्याला sieving effect म्हणते ना सर?
कसला इफेक्ट?
Sieving effect.
सिविंग इफेक्ट नाही म्हणते मी इथे. मोबिलिटी या म्हणजे सिविंग इफेक्ट त्याच्यात इन्व्हॉल्व आहे इलेक्ट्रोफोरेसिस मध्ये डेफिनेटली. बट हिअर वी आर टॉकिंग अबाउट द higher or lower mobility of a molecule by virtue of its atomic size, molecular size rather.
Okay, sir.
Mobility of the molecule is less or more depending upon its size. Sieving effect actually is a combination. When we do gel electrophoresis, we are using two things together. One is the sieving effect and the other is the different mobility by virtue of the size. Okay? And then lastly, we come to another important characteristic of a molecule, and that is the shape of a molecule. Okay, तुम्हाला माहिती आहे का की how can we use the shape of a molecule to separate it? I have 10 minutes remaining. Okay, 10 मिनिटांमध्ये मीटिंग आपली बंद होईल. After that, I will restart the meeting in about a couple of minutes. Okay, so don't go anywhere. Can you answer this question? How are we going to separate a molecule on the basis of the shape of the molecule? आज तुम्ही शांत दिसताय सगळे. पहिल्या दिवशी तुम्ही जेवढे ऍक्टिव्ह होते तेवढे आता काही दिसत नाहीत. व्हॉट इज द प्रॉब्लेम? धीरज फारच शांत आहे. धीरज उठून गेला का बाजूला? मोबाईल जवळ बसलायच की नाही?
Yes, sir.
हा, मला वाटलं पळून गेलास की काय मोबाईल ऑन करून.
नाही sir.
ओके. आणि श्रद्धा तर काही बोलत नाही कधीच.
Yes, sir.
ओके. मग सांगता येईल काय प्रश्नाचं उत्तर की हाऊ कॅन वी यूज द शेप ऑफ द मॉलिक्यूल फॉर सेपरेशन?
No idea, sir.
नो आयडिया. ओके, वंडरफुल. योगिता, तुम्हाला इंडिव्हिज्युअली असं बोलकं करायची माझी एक प्रवृत्ती आहे बरं का. यू मे नॉट लाईक इट प्रॉबेबली. ऍक्च्युली एमएससी मध्ये असं अलाउड नाहीये, म्हणजे काही एक्सपेक्टेड नाही आहे रादर एमएससी मध्ये. पण तुम्ही अजूनही यू आर ॲट द बाउंड्री लाईन ऑफ यूजी अँड पीजी, त्यामुळे तुमच्याकडे इंडिव्हिज्युअली लक्ष द्यावं लागतं आम्हाला. योगिता, आर यू देअर? योगिता दिसत नाहीये जागेवर.
सर आपण एनएमआर स्पेक्ट्रोस्कोपी थ्रू स्टेप वर ते मॉलिक्युलर हे करू शकतो.
क्या बात है, सुनाई नहीं दिया.
एनएमआर स्पेक्ट्रोस्कोपी यूज करू शकतो सर आपण शेप थ्रू जर समज हे करायचं असेल तर.
काय एनएमआर स्पेक्ट्रोस्कोपी सुरू करायचं?
नाही एनएमआर स्पेक्ट्रोस्कोपी
हा,
मॉलिक्युलरचं शेप वगैरे आपण ठरवू शकतो त्याच्यावर.
नाही हे बघ. हा, बरं, काही हरकत नाही. तुम्ही असं चुकीचं बोलले तर उलट चांगलीच गोष्ट आहे. एनएमआर स्पेक्ट्रोस्कोपी इज अ कम्प्लिटली डिफरंट थिंग. ओके, आपण ते स्पेक्ट्रोस्कोपिक मेथड मध्ये शिकणार आहोत. ओके, इट इज बेसिकली अ मेथड ऑफ कॅरेक्टरायझिंग द मॉलिक्युल्स. ओके, इट इज नॉट अ सेपरेशन मेथड. आता आपण जे शिकतोय ते सेपरेशन मेथड म्हणून शिकतो. इज इट ओके?
ओके सर.
ओके, बेस्ड अपॉन शेप. बघा, तुम्हाला एक साधं मी एक्झाम्पल देतो की अँटीजेन आणि अँटीबॉडी. अँटीजेन आणि अँटीबॉडी यांचं इंटरॅक्शन कशामुळे होतं? कशामुळे म्हणजे बाय व्हर्च्यू ऑफ व्हॉट प्रॉपर्टी दे आर इंटरॅक्टिंग विथ इच अदर. म्हणजे इन अदर वर्ड्स, अँटीबॉडी मॉलिक्यूल विल रेकॉग्नाइज ओनली इट्स पर्टिक्युलर अँटीजेन, नॉट एनी अदर मॉलिक्यूल. हे तुम्हाला माहिती आहे.
Receptors.
राईट? रिसेप्टर्स अँड लायगँड्स.
Sir, enzyme and substrate complex.
काय म्हणते मला नाही कळलं शुभांगी.
Enzyme आणि substrate.
वंडरफुल. येस यू आर करेक्ट. हे बघा, एन्झाईम सबस्ट्रेट झालं, त्याच्यानंतर रिसेप्टर आणि लायगँड झालं, आणि तिसरं अँटीजेन आणि अँटीबॉडी झालं. ओके, ह्यांचं जे इंटरॅक्शन होतंय हे कोणाच्या बेसिसवर होतंय, कोणत्या बेसिसवर होतंय? तर ते शेप वरती होतंय. कॉम्प्लिमेंटरी है ना. तुम्ही लॉक अँड की हायपोथेसिस शिकलेले आहे.
लॉक अँड की हायपोथेसिस.
हा, येस. त्याच्यानंतर तुम्ही शिकलेले आहे की सेल्फ आणि नॉन सेल्फ. अँटीबॉडी काय करते की विशिष्ट प्रकारच्या अँटीजेनलाच ते रेकॉग्नाइज करते. तिचा जो स्पेसिफिक अँटीजेन.
सर
येस
सर प्रोब्स से सेपरेट कर सकते हैं क्या?
इससे
प्रोब्स.
प्रोब्स. यस डेफिनेटली. हाँ, प्रोब का भी वही है कि प्रिंसिपल की हियर द शेप इज इन्वॉल्व एक्चुअली. ओके, और कौन सा शेप उसको बोलते हैं कि कॉम्प्लीमेंटरिटी ऑफ शेप, दैट इज कॉम्प्लीमेंट्री शेप्स आर रिकॉग्नाइज्ड बाय द बायोमॉलिक्यूल्स. ओके, तो जैसे मैंने अभी ये हाथ ऐसा पकड़ा है, कैन यू सी मी? हाँ, ये सपोज एंटीजन है और ये इधर एंटीबॉडी है, तो ये कॉम्प्लीमेंट्री शेप अगर होगा तो उसको वो रिकॉग्नाइज करेगी. एंटीबॉडी विल रिकॉग्नाइज द एंटीजन and then it will form an antigen antibody complex. ओके, तो ये जो रिकॉग्निशन है, बायोमॉलिक्यूल का रिकॉग्निशन है, सपोज ये शेप ऐसा हो गया तो ये रिकॉग्नाइज नहीं करेगा एक दूसरे को, isn't it? There is something called as biological specificity, and that specificity is because of the shape. Okay, so there is a very interesting type of a chromatographic technique which is called affinity chromatography. ये देखो मैंने इधर हाईलाइट किया है कर्सर से. ओके, so affinity chromatography is a special technique which is used for separation of biomolecules on the basis of complementarity of the shapes. Is it right? Okay,
Yes.
so move on to the next slide. अभी ये slide मैंने आपको किसके लिए क्यों दिखाई है? Why I have shown you this slide? This is for you to understand that different chromatographic techniques or different separation techniques are there. Okay, and these different separation techniques are based upon the different properties of the biomolecules. Okay, so जितने भी अलग-अलग properties है molecules के, based on their different properties, we have designed certain techniques. Okay, and these techniques are used for the separation of these biomolecules. Okay, so next important slide है ये. This is telling you about the different forces which are involved in the separation of biomolecules. Okay, कौन से forces है separation में? जैसे for example हमने इलेक्ट्रोफोरेसिस में देखा था. इलेक्ट्रोफोरेसिस में कौन सा फोर्स था? इलेक्ट्रिकल फोर्स था.
Electrical force.
Centrifugal force.
That force was used to drive the molecules, okay, or allow the migration or allow the transfer of molecules from one region to the other region. And during the transfer of the molecules, we got separation of the molecules, which was based upon the property of the molecules, different properties of the molecules. Okay, तो इलेक्ट्रोफोरेसिस में हमने क्या किया देखा था? It was actually the electrokinetic force. This is more appropriate term, electrokinetic force, right? तो वैसे दूसरे और कौन से फोर्स हो सकते हैं जिसको हम impelling force बोलते हैं? Can you see this word here? Impelling force. Impelling मतलब क्या? Driving force. वो कौन सा फोर्स है जो मॉलिक्यूल्स को ड्राइव करता है आगे? Okay?
Centrifuge.
Yeah. So we have, for example, centrifugation में देखेंगे तो that is gravitational force, है ना? या centrifugal force बोल सकते हैं आप उसको,
Yes.
right? और तीसरा एक फोर्स है that is called as hydrodynamic force. Hydrodynamic force मतलब क्या? The force which is concerned with the or which is connected with the mobility of water. Okay, water की जो mobility है और flow है, water का flow. Okay, that flow is responsible for movement of the molecules, and in that movement we get separation of the molecules on the basis of their differential properties. Okay.
Yes.
Then there is another force which is involved and that is called the retarding force. Retarding force का क्या मतलब है? That is the opposing force. Okay, मतलब एक फोर्स अगर मॉलिक्यूल को ऐसे पुश कर रहा है आगे तो दूसरा फोर्स उसको स्टॉप भी करता है, उसको हिंडर करता है. You understand what I am saying? Okay, that is called a retarding force. For example, हमने इलेक्ट्रोफोरेसिस में देखा है कि there is a frictional force. क्योंकि जेल में से जब मॉलिक्यूल मूव होता है जेल में, तो जेल का जो स्ट्रक्चर है, that structure is itself causing some hindrance. Okay, there is friction, for example, friction with that material, gel material, friction with the buffer itself. Okay, and that friction is actually preventing the molecules to move ahead. Okay, So molecular friction is there, then electrostatic interactions are there. Electrostatic interaction मतलब क्या? जिस मीडियम में से वो मॉलिक्यूल्स मूव हो रहे हैं, उस मीडियम में अगर कोई इलेक्ट्रोस्टैटिक फोर्सेस हो गए, है ना, इलेक्ट्रोस्टैटिक चार्जेस अगर हो गए, तो दीज चार्जेस और द इलेक्ट्रोस्टैटिक फोर्स इटसेल्फ इज रिटार्डिंग द मूवमेंट ऑफ द मॉलिक्यूल्स. ओके. तीसरा कौन सा फोर्स है? एड्सॉर्प्शन है. एड्सॉर्प्शन मतलब क्या?
Absorb.
एड्सॉर्प्शन का मतलब क्या?
सांस
बाइंडिंग ऑफ
सर इन द सरफेस, मतलब सरफेस में अगर कुछ, हाँ, बाइंडिंग ऑफ a substance in the surface.
Yes, very good. Okay, so it is a force by which,
Sir, for example, as in charcoal.
yes, charcoal is a good adsorber, है ना. तो चारकोल पे क्या होता है?
Black body.
गैस मॉलिक्यूल्स हो गए या कोई फॉर एग्जांपल